Hello everyone, I'm Daphne and I'm a molecular biology student at Bilkent University. Today I'll be presenting my Physics 101 project. The main purpose of my project is to examine energy conservation and energy conversion laws. First, I will calculate spring constant K by using the energy conservation law, and then I will do the same experiments on a surface with friction to observe the energy loss caused by friction. The formula that I used for the spring potential energy is derived from Hooke's law, which can also be seen from here. And these are the equipments that I used for the project. And now I will perform the experiment. In the second experiment, the setup was the same, except I unplugged the air tube so that the surface will have friction and we will observe energy loss. After the experiment, I calculated the velocity of the puck by measuring these distances between the dots on the carbon paper. It can also be seen here that in the first experiment, the distances between the dots are the same, since puck is moving with constant velocity. And in the second experiment, the distances between the dots gradually decreases and the puck eventually stops. These are the results of the experiments. The average energy loss was 0.039 joules, which aligns with the calculated spring constant of 82.32. This reflects the decelerating impact of friction, as seen in the reduced velocity and shorter distances traveled by the puck. This graph compares the distance the puck travels on two surfaces. In the first experiment, frictionless surface, and in the second experiment, surface with friction. This was also observed from the distance between dots. The second graph shows the relationship between potential energy stored in the spring and the kinetic energy of the puck over time on a frictional surface. Ideally, if no energy were lost to friction, the potential energy of the spring would be the same as the kinetic energy of the puck throughout the experiment. However, in this case, the potential energy is higher at the start, and as the puck moves, friction causes energy loss. This also illustrates how friction transforms mechanical energy into other forms, like heat, reducing the kinetic energy of the puck. And in the final graph, we can see that as the puck starts to move, the energy loss is minimal, but over time, as friction continues to act on the puck, the energy loss increases. In conclusion, we can say that energy is conserved in ideal systems, in frictional systems, and in real-life systems with friction, energy is transformed into other forms such as heat. And thank you for listening.